To form a solution, you require a solvent and a solute. Now, a common solvent, of course, is water. So I'm going to add some water to a test tube. And then we can add something like pickling salt. Pickling salt is actually better than table salt because table salt has added to it an agent which makes it free running. And we'll add some of that, and then to mix that, we can then hold the test tube near the top and shake it with our finger, or just shake it like this. And when you look at it, you can see that the sodium chloride or table salt is slowly dissolving. So the water is the solvent, the sodium chloride, pickling salt, is a solute. And we say that we have then a homogeneous solution because we have only one phase present. We can only see the liquid. We cannot see the solid anymore that we added to the test tube. And so we call that a homogeneous solution. In fact, solutions are always homogeneous. Another solvent that I can use is methyl hydrate or methanol, commonly used in the alcohol burners, but also used in windshield washer antifreeze and a number of other important consumer products. I've transferred a small amount into a bottle, and we'll add some methanol then to this test tube. And then we'll add some pickling salt to the methanol. So again, the methanol serves as the solvent and the pickling salt as the solute. In this case, though, the pickling salt is not dissolving very well. And so we have two phases present. We have the liquid phase and we have the solid phase at the bottom. And so we have a heterogeneous mixture. We can actually see the two different things that we have present. The liquid, the methanol, and the sodium chloride. So in this case, we have then the sodium chloride probably dissolving a little bit, but certainly not nearly as much as with the water. And so we have then a heterogeneous mixture. In my third test tube, I'll just put some water again. And then we'll add a few drops of methanol using a dropping pipette. So we'll add some methanol to that. And as I do that, the methanol completely disappears and forms a homogeneous solution with the water. So in this case, the water is the solvent and the methanol is the solute. And so we have, again, a solution being formed. Now let's take some water again. And this time we'll add some vegetable oil. Again, using a dropper, we can add some vegetable oil to that. And when I look at that, we actually have the vegetable oil floating on top of the water. And you can see droplets of the oil in suspension in the water and gradually rising to the surface. Here again we have a heterogeneous mixture. The oil does not dissolve in the water, and as a consequence we have then non-homogeneous system, but actually a heterogeneous system. Two different phases, both of which are liquid. Now let's add some methanol to the next test tube and add some vegetable oil to that. So again, we'll take some of the vegetable oil and just add a half mil or so of the vegetable oil. Well, in this case, the vegetable oil is on the bottom. It does not dissolve in the methanol. So the vegetable oil is thus more dense than the methanol. It does not dissolve very well. And so again, we have a heterogeneous mixture. Two different phases, both of which are liquids, but the liquids do not mix. And we call the liquids that do not mix, we call them immiscible. When they mix, as in the case with methanol and water, we call them miscible. They mix together, and so we say they are miscible. In the case of methanol and vegetable oil, they are immiscible.